Hey everyone, welcome back for another deep dive. Today we're taking on Designing Machine Learning Systems by Chip Huyen. This book, it's basically a roadmap for getting your ML projects from like a idea to actually working in the real world.
It's a fantastic resource, really practical, and covers the whole life cycle of an ML system.
Yeah, and it starts right off the bat with this question. When is ML the right tool? I feel like everyone's so hyped about AI these days that it's tempting to just like throw it at every problem.
Right, like it's some magic wand. But Fuin makes it clear that it's more like a specialized tool.
Okay, so thinking about that, what kind of problems does ML actually excel at?
Think tasks that are really repetitive and happen at a huge scale, where humans would just get bogged down, like sifting through millions of emails to filter out spam, perfect for an ML model.
Okay, so automation is key, but there's got to be more to it than that, right?
Yeah. Absolutely, the automation needs to have a purpose. Chapter 2 really digs into aligning those business and ML objectives, because a model could be super accurate technically, but useless if it doesn't actually solve a real problem for the business.
Makes total sense. It reminds me of that example Huyen gives about personalized recommendations. They might make customers happy, but will people actually buy more? That's the real question, and you have to run experiments to find out.
Exactly, experiments are crucial. And speaking of different goals, Chapter 3 breaks down all the different types of ML tasks. We've got classification, like figuring out if an email is spam or not, regression, like predicting housing prices, and so many more.
Each with its own quirks and best practices, but they all rely on one crucial ingredient, data. And chapter 4 is like a whole deep dive into that world, right? Different formats, models, how to store it all effectively.
It's like picking the right containers for your ingredients before you start cooking, a crucial step. And Huyen talks about this idea of data lakes, which sounds appealing at first, just dump all your data in one place, right?
Yeah, but I can imagine that turning into a nightmare as the system grows.
Exactly. Choosing the right data model, like a relational database or a more flexible NoSQL setup, it's super important for efficiency and being able to scale your system up as you grow.
Okay, so once you have your data all sorted, chapter 5 takes us to feature engineering, which is basically transforming that raw data into something the ML models can actually digest.
It's like preparing your ingredients, right? Chopping veggies, seasoning meat, that kind of thing. With data, you might scale numerical values, create embeddings for categorical features, or even combine multiple features into a new one.
And it's at this stage where Huyen warns us about a big potential pitfall, data leakage.
Yeah, that's like accidentally giving the model a sneak peek at the answers before the test. It'll pass with flying colors, but then fail miserably in the real world.
So one example he gives is randomly splitting time-correlated data.
Right, if you do that carelessly, information from the future can end up in your training data, making your model look way better than it actually is.
So how do we avoid those sneaky leaks?
Huyen gives a few techniques. Carefully designing those data splits is key, and being very mindful of how you use your features. For time-correlated data, he suggests something called backtesting, basically simulating real-world scenarios by using only past data to predict the future.
Okay, makes sense. So now we've got our data prepped and ready to go, and chapter 6 is where the model building fun begins. Finally.
It's time to choose the right model for the job. And there are a ton of options. Huyen goes into the pros and cons of different types, the power of combining them in ensembles. And then there's hyperparameter tuning.
Which is basically fine-tuning the model to squeeze out that extra performance.
Exactly, and Huyen emphasizes that it's not just about getting the highest possible accuracy. Robustness matters too, as does fairness. You want a model that makes sense in the real world.
So you might have a model that's super accurate overall, but if it performs poorly on certain slices of your data, that's a problem. Like, for example, if it's biased against certain demographic groups, that raises some serious ethical flags.
Absolutely, and that's something we'll be digging into more as we go deeper into the book, so stay tuned for more of this deep dive.
Okay, so we left off talking about how important it is to think about the real-world implications of our models, like fairness and potential bias.
Right, and Chapter 7 dives even deeper into that, especially when it comes to deployment, getting our model out of that nice, safe testing environment and into the messy real world.
Where the data might not always play nice, right? Like we talked about with data distribution shifts.
Exactly, and Chapter 8 tackles this head-on. How do we make our models robust enough to handle those ever-changing landscapes?
I imagine retraining is a big part of it. But how often do you actually need to retrain? Doing it too often seems like it could be a huge drain on resources.
It definitely can be. So Chapter 9 kind of picks up where we left off with that. It actually starts with the idea that retraining doesn't always have to be this massive undertaking.
Oh, interesting. So not like cramming for a final exam every few months.
Right. Huyen starts with this idea of manual and stateless retraining. It's like sending your model for a quick refresher course every so often, just to keep it up to date with any minor changes in the data.
Okay, so that's a good starting point for teams that are maybe just getting started with ML.
Exactly. But as your system grows, and you need to update it more frequently, you might move towards automated and stateful retraining. And that's where things get really cool.
Stateful retraining. Sounds fancy. What's the advantage there?
Imagine you have a student who actually remembers what they learned last semester instead of starting from scratch each time. Stateful retraining allows the model to build on its existing knowledge, which makes the whole process much more efficient, especially when you're dealing with huge data sets.
Cool, so the model is constantly leveling up. But how do you know when it needs that extra training? I imagine retraining too often could get pretty expensive.
That's where monitoring and evaluation come in. Chapter 9 really stresses understanding the value of data freshness. Like, how much does using newer data actually improve your model's performance? It's about finding that sweet spot between how often you update and the cost of doing so.
Kind of like finding the right balance when you're watering a plant. Too much and you drown it, too little and it wilts.
Perfect analogy. And we can't forget about testing, even in production. I know it sounds scary, but Huyen makes it clear that this is essential for catching any issues early on.
I get why you'd want to do that, but isn't it risky to test on live data? What if something goes wrong?
There's always some risk, but Huyen outlines ways to minimize it, like shadow deployment, which is kind of like having an understudy practice backstage before taking on the lead role. You run your new model alongside the existing one, compare their predictions, but without actually impacting any real users.
Oh, that's clever.
Yeah.
Less drama and more control over the experiment.
Exactly. And then there's A/B testing, where you expose different versions of your model to different groups of users and see which one performs best. It's like running a taste test to see which recipe people prefer.
Love the food analogies.
Yeah.
But speaking of well-oiled machines, Chapter 10 takes us into the back end of all of this, the infrastructure and tooling that make MLOps actually work.
Right. This is where we get into the nuts and bolts. Think of it as setting up your workshop. You need the right tools, workbenches, storage solutions, all of that. So Huyen walks us through the world of cloud providers, containerization, those fancy orchestration tools, and of course, the all-important feature stores.
Full disclosure, this is the part where my eyes start to glaze over a bit. It's a lot to take in.
It can be pretty dense, yeah. But Huyen breaks it down pretty well. Like, he talks about the advantages of cloud computing, easy to get started, super scalable. But you also run the risk of costs spiraling out of control if you're not careful.
So it's like renting a fancy kitchen versus building your own, right? Convenient, but potentially pricey.
Exactly. Choosing the right infrastructure is all about finding the right fit for your specific needs and your budget. But tools are only as good as the people using them. And that brings us to Chapter 11, where things get really interesting because we shift our focus to the human side of machine learning.
The human side, we've been talking about algorithms and data this whole time.
Right, but these systems don't exist in a vacuum. They interact with real people, and those interactions can get really complex.
Okay, so what does Huyen have to say about all of that?
Well, he starts with user experience. It's easy to forget about UX when you're deep in the technical weeds, but it's absolutely crucial if you want your model to actually be useful in the real world.
Right, because what good is a perfect model if people find it confusing or frustrating to use?
Exactly. And one of the biggest challenges he highlights is the inherent probabilistic nature of ML. Like, how do you design a system that feels reliable and consistent when the underlying model is dealing with probabilities and uncertainty?
Yeah, that's a good point. We as humans like things to be predictable.
Right, and Huyen uses this great case study from Booking.com where they tried to improve their filtering system with ML. But the suggestions the model was giving were so inconsistent that users just found it confusing and frustrating.
So even though they had good intentions, the execution kind of backfired.
It did, and it's a reminder that we need to think beyond just those raw performance metrics and consider how the model's output will be perceived by real people.
That makes me think about transparency, too. If users can understand how the system works and why it's making certain recommendations, they might be more forgiving of those occasional inconsistencies.
Absolutely. Transparency builds trust. It's like knowing the chef who prepared your meal.
Yeah.
You might trust the food more knowing that it was made with care and attention.
I like that analogy. And speaking of teams, Huyen also emphasizes having the right people involved in building these systems. It's not just about having the best data scientists.
Right, it really does take a village. He argues that cross-functional teams are essential. Data scientists, engineers, product managers, designers, even ethicists if the system warrants it.
So breaking down those silos and making sure everyone's on the same page.
Exactly. When everyone has a shared understanding of the system's goals and its potential impact, you're much more likely to create something that's both effective and responsible. Which brings us to, I think, the most important part of the book, the part about responsible AI. It's not just a buzzword, it's a crucial consideration for anyone building ML systems today.
Okay, so we left off talking about responsible AI, which feels more relevant now than ever. Like it's not just a nice to have, it's got to be baked into the whole process of building ML systems.
I completely agree. And the last part of Chapter 11 really drives that point home. Like Huyen lays out this framework for identifying and mitigating bias, making sure there's transparency, and being honest about the limitations of our models.
And this is where I think things get really interesting because it's not just about the technical stuff anymore. It's about ethics, about the impact these systems can have on people's lives.
Absolutely. And he gives some really concrete advice about how to actually put those principles into practice, like auditing your model's behavior, really scrutinizing your data for potential sources of bias. And then there's this idea of creating model cards.
Model cards, what are those?
Imagine a nutrition label, but for your ML model. It basically lays out all the key information, how it was developed, what data was used, what its limitations are. It's all about transparency.
So anyone using the model can understand how it works and what its potential biases might be.
Right, and it forces us as developers to be more thoughtful about the choices we make, like which metrics are we optimizing for? What are the potential unintended consequences of our design decisions?
It's like a reminder that we're not just dealing with code and algorithms, we're dealing with real-world impacts.
Exactly. And the UK A-levels grading scandal is a perfect example of what can go wrong when we forget that.
Oh yeah, that was a mess. A perfect case study in how biased algorithms can really harm people.
And it all came down to optimizing for the wrong thing. They were so focused on matching the historical grade distribution that they ended up reinforcing existing inequality.
It's a cautionary tale, for sure. But it also feels like a call to action, like we have a responsibility to do better.
We absolutely do. And I think that's the main takeaway from designing machine learning systems. It's not just about building smart algorithms, it's about building a better future.
I love that. It's not just about the tech, it's about the human element.
Exactly. So as you go out there and build your own amazing ML systems, keep asking those critical questions. Challenge your assumptions. And always strive to build systems that are both effective and ethical.
Couldn't have said it better myself. Thanks so much for taking us on this deep dive. It's been really eye-opening. And to everyone listening, keep learning, keep exploring, and let's build a future where AI benefits everyone. Catch you next time.